All right, hello everyone. This is part one of the final review. I want to start out with a problem we had the most problems with on the last test. And I don't know what it was, maybe we overthought it, but we're dealing with similar triangles in a problem like this. Basically what we have here are two triangles, and if you don't see it, redraw them. We have this large triangle going from the curb to this building and all the way up to this person's eyes. So go ahead and redraw this triangle. Okay. And we have this smaller triangle from the curb to the flagpole. So I'm going to go ahead and redraw that triangle as well. That'll help me see it. Now I know these are similar triangles. What is the giveaway for similar triangles? Well, one, I can see that I have a little triangle sitting on top of a bigger triangle. So they share this angle. And from the building, we have a perpendicular line. We're going to go straight up here. So we know that these are 90 degrees. So by the AA similarity, I know that, yes, these two triangles are similar. And since they are similar, we can assume that all the sides are proportional. All the angles are congruent. So let's go ahead and transfer our values. So for the big triangle, from the curb to the building, it's about 20 yards. Okay. This is where you got to be very careful. Okay. From the flagpole to the building is 12 yards, but the entire distance is 20 yards. So we can go from the curb to the flagpole is about 8 yards. And plus 12 gives us 20. So don't forget that. And that's where a lot of people would make their easy mistake on this and get the problem completely wrong. We know that the height from the ground all the way up to Carla's eyes here are about 15 yards. And what are we looking for? We're looking for the height of the flagpole. This might help you see it much better if you redraw the triangles, relabel them with everything, but be very careful in this part. We know the distance is 20, part of it is 12, so be very careful with this. We're really making you think about these problems. So there's two ways we can go about it. We can find a scale factor. Let's start with that first, or we can set them up in proportions. Both of them work. So our scale factor in this case here, and it looks to me we went from we're looking to go smaller because we're looking for the height of the flag. So we want to set it up with a small number on the top and the bigger number on the bottom. Well, you put that in your calculator, and all you need to do is do it in your calculator. What's 8 divided by 20? 0.4. I'm going to take that scale factor, which is 0.4, and I'm going to multiply it by the height of that building times 15. So the height of the flagpole is 6. We can also set it up the proportional way, right? We got 8 over 20 equals, we have the height. Notice how I'm going to keep all my small numbers on the top and the small triangle, all my numbers, and the big triangle on the bottom. So be very careful with that. And 15. We're going to cross multiply. So make sure you're using your calculator. 8 times 15. That's 120. And I know it's going to be 20 times h, which would give me 20h. And then I'm going to divide both sides by 20. So h in this case equals 6. Okay, same thing we got with our scale factor. If you're comfortable with the scale factor, use scale factor. If you're comfortable with setting up proportions, use proportions. I'm more of a proportions person. I noticed that most people in our classes are more comfortable with scale factor. All right. So be ready for a problem like this on the final. Since we did so poorly on the test, expect to see it on the final. And be very careful about how you set these problems up. I think what a lot of people made the mistake with is they set this part up at 20/12 or 12/20, and I think that's kind of where things kind of went sideways for a lot of people. All right. Other things I want you to be very aware of, and I'm going to evaluate, not so much that you know these definitions, but you know how to apply them. Like, know how to apply the angle addition postulate. Angle addition postulate says if point D lies in the interior of angle ABC, then the measure ABD plus the measure of DBC equals the measure of ABC. What are they talking about with this? Well, think about, we have this angle. Right, this angle is angle A, B, and C. And there's this other ray coming out, D. Well, they're saying that, hey, angle ABC equals, hey, good morning, angle ABD plus angle DBC. That is angle addition postulate. Make sure you can apply it. The next postulate I want you to be able to apply is linear pair. If two angles form a linear pair, then the angles are supplementary. So what are they saying here? Anything that's supplementary is 180 degrees. Whenever you see a flat line and you see angles on that flat line, you know, no matter how many angles are on there, they're going to add up to 180 degrees. But a linear pair is very unique. It's just two angles. These two angles happen to be adjacent to each other. We have an angle here, we have an angle here. And if we add these two angles up, they're going to equal 180 degrees. Very important postulate for you to apply and be able to talk about in the upcoming final. And the next one is the segment addition postulate. If point B is on AC and between points A and C, then AB plus BC equals AC, or the measure AB plus the measure BC equals the measure of AC. So we have some line segment. Let's call this line segment AC. And we have some point in the middle. Doesn't matter where. Let's call this B. What they're saying is that the entire line segment, AC, from here to here, equals the addition of that line segment. So we're going to take those parts, AB, from here to here, and we're going to add it to this parts here, BC, which will equal the entire line segment. That's segment addition postulate. So how do we apply these things? And I want to work on a segment addition postulate next. How do we do a proof like that? And then maybe later on, we'll get into angle addition in another video. So step one. Step one is make a plan. How are you going to go about solving a problem like this? And this one's a little bit different. Now, unlike triangle congruency problems, you have a triangle, you have a diagram you can mark up. Here, you got to understand some parts you're going to need. Like our given. What does our given mean? AB is congruent to CD. That's important, right? And I want to prove that AC and BD are congruent. So AC is from here to here, which includes AB plus BC. And then BD is this entire segment from here to here, which includes BC and CD. Well, right off the bat, make that list. Make a list of those parts. Maybe you'll use some of them, maybe you won't. So let's go ahead and do that. So what do we got here? What is AC? So AB plus BC equals AC. All right. And then we know that BD is CD plus BC equals AC, AC equals BD. Okay. And then you notice how we have BC in here twice. We need to be able to talk about that. Because if we're going to say that AC and BD are the same, if this distance from here to here, from AC, is the same as the distance from here to here to BD, we have to talk about this part being the same. We already know that AB is the same. We already know that CD is the same. So let's go ahead and put that down there. BC is congruent to BC. That's our reflexive property. Very useful to have and talk about. So make sure you do that. All right, and so I think that's how we're going to go about doing it. We're going to show that, hey, you know what? We know that AB and CD are the same. That's our given. So we know that the measure of AB equals the measure of CD. I think we'll talk about that. We're going to talk about the fact that these two are the same. And if these parts are the same, then we can use some substitution. Why not? All right. So let's go ahead and talk about those parts. Let's talk about those parts. Very first thing, and I wrote some of these parts down over here. I'm going to write them down a little bit different over here, but list your parts, right? Don't forget your most important part. Without your given, all of this goes by the wayside. This entire proof is worthless. So make sure you do that. So we're going to write down the first thing. We're going to write down here, AB is congruent to CD. Okay, that's our given. You have to talk about why this is important. Why is this important? Because the measure of AB equals the measure of CD. That's useful. Right? The measures are very, very important to talk about. We're saying that this length is exactly the same as this same. They're equal in length. They're the same thing. We want to go from congruency to equality. All right, so what's the next thing we want to talk about? Well, what about what we were talking about earlier with the reflexive property? I know it's not on this list here, but that's an important part to put in there. BC, the measure of BC, equals the measure of BC, because that's a reflexive property. And then we want to talk about all of these parts. Right? We're saying that from here to here is the same as from here to here. Well, let's go ahead and make that statement. So we're going to go ahead and write it out. We're going to write out AB, the measure of AB, plus the measure of BC equals the measure of BC plus the measure of CD. Okay, that's important to talk about. Right? We're saying that the distance from here to here, from here to here is the same as the distance from here to here, and we want to make that statement. All right, and then we want to be able to describe what's going on from here to here. So the measure of AB plus the measure of BC equals the entire measure of AC. Oh, we got to put the measure in there first. And then I'm going to go ahead and say the same thing here. The measure of CD plus the measure of BC equals the measure of BD. Well, since we showed that AB is the same as CD, then we can go ahead and use a little bit of substitution. We have a little bit of equality going on here. Since this piece is the same as this piece, because we show that AB and CD are exactly the same. We already showed that BC and BC are exactly the same. We can go ahead and write this part right here, the measure of AC equals the measure of BD. Now that we got it down to here, the measure, remember your very last statement. And when I was grading your test throughout this quarter, this is where we kind of fallen apart. At this part, we did really good all the way up to this point, and then we forgot, what are we trying to prove? We're trying to prove that AC is congruent to BD, not that the measure of AC is equal to the measure of BD. So we need to be able to convert that over. So the very last line that you should ever write on any of your proof is what you're trying to prove. So we're going to go ahead and switch this over. AC is congruent to BD. So we got our parts. Nice. We still have to fill out our reasons, and our reasons are very important. We have to be able to say, why are we allowed to say this first section? Why are we allowed to say that AB is congruent to CD? Well, that's given. Then why are we saying that the measure of AB equals the measure of CD? Well, that's our definition of congruent segments. Why are we saying that the measure of BC equals the measure of BC? Well, that's our reflexive property. And in this statement here, why we're saying this? Well, this is where it's a little bit tricky. This is our addition property. I lost my thought. There we go. What's going on with this statement? Well, this is our segment addition property. And I could say the same thing about this. So I'm lazy. I'm just going to put these little quotation marks in. From what happened from here to here, well, we're saying that, hey, AB plus BC is the same as CD plus BC. So we're going to go ahead and substitute. We're going to substitute those pieces out. And so this is substitution. And lastly, why are we going from here to here? Well, this is our definition of congruent segments. Okay. It's a strategy. It's one strategy. There's more than one way to solve this proof. I'm just giving you one way. Step one, don't forget, very important step is make a plan. Make a plan. If you're not making a plan, and you're just kind of winging it, and winging it's not going to get you anywhere. Step two, make sure you list your parts. And then step three, of course, is give all your reasons. Make sure that the very last line that's on your proof is what you're trying to prove. Make sure that the very first line that's on your proof is your given. Right? And yeah, there's a lot to think about. We're using a lot of properties on here. We're using addition property, using segment addition property. We're using reflexive property. We're also going and talking about definition of congruent segments. And so as we go through these proofs, We're going to constantly be using these type of properties. Make sure you know how to use these properties, right? Make sure you know how to use the addition property, the subtraction property, the reflexive property. And we just somewhat use that on that last proof. We also use substitution property. Transitive property, be very careful with saying transitive property. Most people tend to mix these two up. And I totally get it. They're both talking about equality. But transitive property is probably the most misused property this quarter on many of our proofs. Either we didn't use it when we should have, or we used it when we shouldn't have. So very carefully, and what it's just saying here is if A and B and C are real numbers, and if A equals B and B equals C, then A equals C, right? So we know that A equals B, and we know that B equals C. So they have the same value. They have the same equality. So use it. Use that fact. If these two are the same, then you can go ahead and jump to this conclusion that A equals C. So it's dealing with equality. That's what all it's doing. Kind of similar to substitution, but very different. All right. Sorry, that's the end of part 1 of your final review. There will be a part 2. It's going to be a little bit older version. I made it last quarter, so bear with me on that, but it's the same material you should know. All right. That's all I have. Happy studying.